Hello everyone, and welcome back to another R tutorial video. And in this video I want to talk about how we can start to edit the appearance of the different layers that we're including in our tmap map. And if you remember back to our multiple layers video, I sort of cheated a little bit and I used the call parameter. In fact, you can see the code right up here, the col parameter. And that's one of the more common ways that we have to edit the appearance of layers. And what I want to do before we go through any examples is I just want to throw out the names of these and sort of explain the 6 most common parameters you're going to see across all the different tmap functions. And also, this does harken back to ggplot as well. You'll see a lot of these appear in ggplot also. But I want to go through what they are, explain what the parameters mean and what it means when you change the value. And we're going to start off with color, and I'm just going to make them in comments here so they don't affect our code. So the first one is color, or COL, and this is color. And you can pass in things like red, green, blue, and you can also pass in strings of other colors that are generated from, for example, our color brewer. And I'm going to show you a website in just a second that has a whole list of things that R will accept as colors. So that's the call parameter, COL. The next parameter that you will often come across is LWD. And LWD stands for line width. And the way that line width works, this is a little bit counterintuitive, is R has a default value of 1. And that 1 stands for the width of a piece of text. I know that doesn't make a whole lot of sense, and honestly, it doesn't really matter that much what it stands for. What's more important is that line width is denoted as a float between 0 and arguably infinity. But basically, when you put a value in for LWD, you are referencing that default line width of 1. So if you were to put something as, say, line width equals 2, right, that's going to be interpreted as make the line twice as wide as a default of 1. So interpreted as x times the size of a default of 1. So 2x would be twice as wide, and 0.5x would be half as wide. So fractions make it thinner, and then numbers greater than 1 make it wider. Hopefully that makes sense. And LWD is something that you're going to have to play with to kind of get the size that you want for a given application. Next, we have LTY, and this is line type. And line type is basically controls the appearance of a line. And what I want to do is I want to show you how this works in practice, because what you end up doing is you end up these are integers between 1 and 6, and each number represents something. And there's a perfectly good table available online at this website here, the stats methods and advanced graphs parameters. I'm going to pull that up really quickly, and I'm just going to show you this is the site that I'm talking about. And if you scroll down, it talks about text and symbol size, talks about plotting symbols, which we'll talk about in just a second. But then you get down here to line type. And line type, as I said before, integer values 1 to 6. And if you type these in, if you have 1, which is the default, you'll get a solid line. If you were to do 3, you get a dotted line. If you were to do 5, you get a slightly thicker dashed line. So hopefully that makes sense. These are the options available to you for line type, and that's LTY. So let's go back to R for a second. That's line type. The next one that you'll often see is size. And size works just like line type. This is the size of a point. And this works just like LWD, or line width. Right, there's a default size of 1, and then everything else is referenced to that. So just to sort of show you what they say for the default, if we do, let's do tm underscore dots. All right, if we scroll down, you'll see that tm underscore dots has a default size of 0.02. And if we read here, right, it says that the shape data variable, the reference value size equals 1, corresponds to the area of symbols that have the same height as one line of text. So again, that isn't super important. What's more important is just the fact that everything is relative to that. So again, if you do 0.5, you're going to go half as big. And if you go 2 times, you're going to be twice as big. And then again, just to sort of point out, for tm underscore dots, right, the default for size is 0.02. So we've already gone way smaller than the default. So I'm just going to quickly copy this because it's the same sort of thing. And again, it's that sort of multiplicative, 2 times wider or half as wide or half as big. So that's size. Hopefully that makes sense. Next, we have shape. And this controls the shape of a point. Now, as I mentioned when we did line type, I went to that website and I said we would be coming back to those, the PCH table. Let's go ahead and go back to that and I'll explain how shape works. So just like line type, where you had integers between 1 and 6 that controlled how the line looked, we have something very similar with plotting symbols, or PCH. This is what it is referencing when you put shape, right? You're referencing this table here, 0 through 23, and there are a lot more. These are just basically, if you go past like 26, you start getting into things that are probably not useful in terms of using them as symbols. But again, you can see how we have an integer number that corresponds to a specific shape type. And we'll go through and we will explain with some examples how these things look. The biggest thing is 21 through 25. You get to have a border color and a fill color. 15 through 20, you get to have just a fill color. So you can see that everything 14 to 0, these are all empty. 15 through 20, you have color. And then 21 through 25, you have both color and border. So you can play with those. But again, the whole point here is you have a table with some numbers that correspond to the shapes. Okay, so uses an integer to reference a table of shapes. Right. And then the last one you'll sometimes see is alpha. So alpha works in conjunction with color. And whereas color specifies what the actual color is going to be, red, green, blue, pink, etc., alpha controls how transparent the color is. Right, and you use a value between 0 and 1, with 0 being completely transparent. So if you put a value of 0 for your alpha, you will come out being completely transparent. So hopefully this made sense. I know we didn't actually do any R code, but hopefully just sort of outlining the 6 most common parameters for editing appearance. Hopefully that helps. Hopefully it makes sense. And in the next video, we'll do a couple of examples showing how we can implement these into our code to make things look different. So again, if you have any questions, please reach out. Thank you.